So now that I kind of explained how to, actually write code and how to download Python, we can talk about some basic Python concepts. And note that I did call this section Basic Python Concepts because if you are familiar with R or MATLAB or another language, like some of you mentioned in your introductions, not everything that I'm introducing here is going to apply to those other languages. These are Python specific. So the first concept that we're going to go over is variables. So these are just names that can be used to reference a stored value. So if we have this line of code, x equals 5, x here is the variable name. The equal sign is what we call the assignment operator, and the number 5 is the stored value. So basically what this code does is that it creates a new variable x, and then x is assigned to store that value 5. And any code you write below this line referencing x will basically be referencing the value 5. The value of a Python variable can change. This may not necessarily be true for other languages, but in Python it does change. So for instance, if you create a variable named x and assign it the value of 5, you can then reassign x the value of 6, and x will evaluate to 6. Alternatively, you can also create a variable x assigned to the value 5 again, and then you can actually assign to x the current value of x plus 4, and x will actually evaluate to 9, which is the result of 5 plus 4. Note that this is a big mistake that people tend to make, especially if you're a beginner to coding. Values will not be saved unless you store it in a variable. So for instance, if you have x equals 5, and then you just type x plus 4, it does evaluate to 9, but if you try to look at what the value of x is again, you'll see that it's still 5 because you did not store the value 9 anywhere. So if you're writing a long program and you're not saving your values, you are going to lose a lot of those computations that you've done. So moving on, you might have noticed that I repeatedly mentioned the word value in the previous few slides. What I mean when I say value is usually referring to one of the basic data types in Python. This lecture isn't going to cover all of the data types that you might run across, but these are a couple of the most common ones that you'll see. And the first one is just the string data type. Usually it's str. And this is just a sequence of text characters. So in Python, strings are denoted with either the double quotes or the single quotes. Don't mix the quotes. If you start with double quotes, end with double quotes, same with single quotes. So for example, both of these strings are valid in Python. So double quote hello world or single quote ASDF. Integers is another common data type that you'll see in Python. These are just positive or negative whole numbers, pretty similar to the mathematical definition of an integer. So 2023, negative 2023 are both integers in Python. There's also floating point numbers or floats, and these are just numbers with a decimal point. So 12.5 and negative 1.33 would both be floats in Python. Another type is the Boolean. This is a logical value that can only be either true or false, and you'll just see it written as true or false. And the last data type that I'm going to be discussing in this lecture specifically are lists. So these are just a collection of values in a sequence. Lists are usually denoted with the square brackets and commas separating each item. Not all the values in a list have to be the same type of value. So you see that the first list has all integers, but the second list has a mix of strings, integers, and booleans. Both of these are valid lists in Python. So a quick note on strings and lists. You might have noticed that I defined both of them as sequences in Python, and you can consider a string a sequence of different characters and a list as a sequence of different values. And what this means is that because they're sequences, they can actually both be indexed. This just means that each item in a list or a string can actually be referred to by its numerical position from index 0 to index n-1, where n is the total number of items. And the notation is just using square brackets. You'll have list, square bracket, the position you want, or string, square bracket, the position you want. Make sure you note that the indices do start from 0. So even though if you're counting in that first example list, A is the first item in English, it is at index 0. And that's why when you index the second position in my list, you actually get the character C. Sequences can also be sliced. So you can actually index multiple items at once. And the notation is just list brackets start position colon end position, or similarly for string, you have the start position colon end position. Note that the value at the end index is usually not included. So if you're familiar with mathematical notation, the slice from 0 to 2 really means the interval 0 inclusive, 2 exclusive, or you're looking for everything that is greater than or equal to 0, but less than 2. So for instance, if you just want the first 2 characters or just the first 2 strings in my list, you can do 0:2, and you'll see that indices 0 and 1, which are A and B, are included, but index 2, which is actually C, is not included in the result. Also, just a quick shortcut, if you're slicing with the first or last position, you can actually leave off the position number. So for instance, if you're just interested in everything that's before a specific end position, you can just do colon end position. Or if you're looking for everything starting from one position all the way to the end, you can just do start position colon and then end bracket. So if we just want the first 5 characters in this example string, we can just do open bracket colon 5 close bracket, and you'll see it only returns the first 5 characters. So Python also contains operators, which allow us to perform actions on different variables and values. Earlier, I discussed the assignment operator and the addition operator in this example. So the assignment operator is the equal sign, and the addition operator is the plus sign. There are a lot of other common operators. Again, this list doesn't include all of them, but these are some of the ones that you might see a lot. And usually they're pretty self-explanatory based on their name. So you have some arithmetic operators such as subtraction, multiplication, and division. And these are usually used on numerical values, so integers or floats, and they'll return a numerical value. So you can see on the bottom left, if you do -45 and then -15, you'll get -60. You can do 2 times 0.5, you'll get 1.0. There's also comparison operators. So those are equals or not equal, greater than, less than, greater than or equal to, and less than or equal to. And these can be used on numerical data types. So you can see in the bottom left again, I have 5 is greater than or equal to 3. You can also use them actually on strings or Booleans themselves, which are in the bottom right. So you'll see that if you actually look at if the string A is greater than string B, it'll return false. And this is because it'll look at the alphabetical order. So A comes before B in the alphabet. So it's actually A is less than B if you use the less than operator. You can also see that Python is case sensitive. So for instance, all lowercase hello is not equal to all uppercase hello. And if for some reason you're ever in a situation where you need to compare Booleans, you can just compare true and false, and you'll see that they are not equal. And comparison operators will always return a Boolean value. So they'll always return true or false. Moving on, another thing that's important to note in Python are functions. So functions are blocks of predefined code that must return some value. They're usually defined using this def keyword, and they can also take parameters which allow external values to be passed to the function. So here on the left, I have this function that I've defined. I've called it first5. So this is just the function definition, this entire block. And there's a parameter, which is input string between the parentheses. Basically, what this function will do is it'll take whatever value is represented by input string, it'll slice the first 5 characters, and then return those first 5 characters back to the user. To use a function, you do have to call it. So that's the second blue box. You'll see that I've actually called first5, the function, on the string hello world. Basically, hello world will now be referred to within the function as the input string. And if you print the result of that function call, you'll see that it does give you the first 5 characters of hello world, which is just hello. Python also supports conditional logic. So in English, this would be if some condition is met, then we run the code. So let's say that we want to see if a given number is negative. So we can, on the left, we can set this num equal to -5, and then we can check this condition. If num is less than 0, then we print the word negative. So in the example above, num is less than 0 is the condition, and so it evaluates to true or false. The condition must always evaluate to either true or false. And if it evaluates to true, only then does the code within the if block run. So you'll see that on the right, now if we set num to a positive value, 1.23, because the condition evaluates to false, because 1.23 is not less than 0, we don't print anything because the code underneath the if block is not run at all. Alternatively, if we did want to handle cases where, for instance, we actually also want to know if that number that we've given it is positive or negative, then we can add this else keyword. So in English, this would be if some condition is met, run some code, else or otherwise, run some other code. So once again, we have num equals -5 on the left, and we say that if num is less than 0 is true, then we print negative. Otherwise, else, we print positive. So we'll see that because -5 is less than 0, then the if statement values to true, and we'll print the word negative. On the right, for the same example as before, if we set num to 1.23, we check if num is less than 0. This evaluates to false, so it jumps to the else block, and the code within the else block is now run, so it actually prints the word positive. Finally, we can talk about for loops. So these are just a way to iterate over sequences in Python, or basically go through each value in a sequence in order. So let's say we have this example list, my list, which has 3 strings, A, B, and C. We can use a for loop, and the syntax is for val in my list. We want to print out each value. So basically what this code is actually doing is that for each of the values in my list, the variable val is assigned to each value sequentially. So it's assigned to the first value and then reassigned to each sequential value after the first value. And then whatever value is currently represented by val will be printed out. So you can see that if we run this code, A, B, and C are actually printed out in order. So I mentioned earlier that there are a lot of different code libraries that are available for Python. And again, these are just collections of predefined code that can perform specific or more complex tasks. And the usefulness of libraries is that you don't need to reinvent the wheel. Chances are that anything you're trying to do, someone else has also tried to do before. And there's probably code out there that someone else has written that does what you want to do exactly how you want to do it. So there's a couple of popular libraries that you commonly use or will see in the fields of bioinformatics and data science. The first is NumPy, which covers a multitude of mathematical and statistical functions. There's also Pandas, which kind of allows you to manipulate large data tables. So for those of you who are interested in RNA-seq, you might be using this a lot. There's also scikit-learn, which offers a lot of machine learning algorithms for classification, regression, and clustering, among other things. And there are also visualization libraries that you can actually use to visualize data, like matplotlib is one that's pretty commonly used. In order to use a library, you do have to install it on your system. So the most common method is to use what is called the pip package installer. And this should come with any version of Python that's 3.4 or more recent. And basically how you do this is in your terminal, you can just type in pip3 install and then the package name. So you'll see here that I'm installing NumPy on my system. So I type in pip3 install NumPy. And this will look different for different packages, but you should see something like successfully installed NumPy and then the version number, or the package and then the version number if it worked. In addition to installing library, you do have to import libraries into each of your Python documents or scripts that uses it. And how you can do this is you can use import and then package name, or in the cases of some libraries, you'll do import package name as an abridged name. And this is just purely based on convention. For instance, NumPy is often imported as NP. This is just how it's done. If you go on the NumPy documentation, they will also tell you that this is the convention. It's not required to do this. You can just import NumPy and then just call it as NumPy throughout your code. But it is good to follow convention when you can, because that's how other people are also writing their code. So on the topic of NumPy, I'll give a very, very brief introduction to what NumPy actually is. So it stands for Numerical Python. And to expand on what I said earlier, it provides specifically a lot of functions for working with multi-dimensional arrays. And so the cornerstone of the NumPy library is basically this np.ndarray object, which actually allows you to store those multi-dimensional arrays that you might have from your data. And that makes it pretty useful for linear algebra. You can do a lot of useful matrix and vector transformations or computations using NumPy, and it'll be a lot more computationally efficient, I think, both memory-wise and time-wise, than just trying to store all your data in the standard Python lists. If you're interested, I've linked their very basic tutorial for beginners here on this slide. And also I wanted to note that if you're using a library in Python, usually you can call functions or variables from a library using the dot notation. So for instance, in this example, if we want to create just a one-dimensional NumPy array, or basically just a vector, we can use np.array and then pass to it the actual values that we want in that vector. I'm also going to briefly talk about pandas, which is another library that you'll probably see and use a lot, especially, like I said, if you're working with very large data sets, because this library, it's built on top of NumPy, and it makes it very easy to create and kind of wrangle large sets of like tabular data. And like NumPy, pandas is also usually imported as a shortened version of its name. So you'll usually see the convention is to write import pandas as PD. And one of the main benefits of using pandas is that it allows you to actually read from and write to standard data table formats. So if you have data in a CSV file or a TSV file or even an Excel file, you can actually use the pandas library to import this directly into your code. And this will be done using the pd.dataframe object, which is basically just an object that allows you to store that sort of tabular data. And then let's say that you modify the data in that table, you can actually then also write all of that data back to a CSV, TSV, or Excel file. So this prevents you from having to copy all of your data into Python, which is going to be really time consuming and also leave you prone to errors. Instead, you can just directly read and write these data tables. Pandas also has a couple of useful functions that allow you to just directly generate visualizations from the tabular data that are built to work with the data frame object they already have. So you don't have to necessarily use another library to actually see the visualizations of the data that you already have. And similar to NumPy, they also have their own Getting Started with Pandas tutorial for beginners, which I've linked on the slide. You can also look up the documentation, and it should be online. And once again, we use the dot notation to kind of call any functions or variables from this library. So if we wanted to just construct a very simple 3x2 data frame object, or you can think of it as like a 3x2 little table, you can just do pd.dataframe and then pass to it this matrix of values. Okay, so that was a lot of information, but in summary, all that information kind of made distilled down to these few points. So in Python, values can be assigned to variables. Python supports several different types of values. We went over a few of them, including text, numerical values, and also lists. You can perform different operations on values and variables using either operators, or we also saw sequence indexing and slicing. You can also use functions, which are defined code blocks that return some value to complete any tasks in Python. And finally, popular Python libraries like NumPy and Pandas are commonly used in data science applications and can be installed and imported into any of your Python scripts as needed. So once again, some other resources, in addition to the resources I linked on individual slides, W3 Schools also has a great introduction to Python that also talks about a lot of the concepts that I just introduced here. You can also look at the NumPy documentation and the Pandas documentation itself, especially if you are already familiar with either of those libraries or you're familiar with Python. Those documentation sites will actually go into a lot more detail than I've gone into here. All right, and with that being said, I would like to thank everyone in the Mayan Lab for their support, as well as all of our funding organizations and partners.